Okay, so we're going to be reading about something called conservation of mass. So let's go ahead and start by reading this article together, adding it up. You can see there's a picture of some salad ingredients, and then we're going to be talking about what happens when you put those ingredients together, what happens to the mass. What happens to the mass of substances during physical or chemical changes? During physical and chemical changes, matter may change its appearance or its identity. In either type of change, the total mass of the matter before and after the change remains the same. This is called conservation of mass. To conserve means to save. For example, as water boils, it seems to disappear. However, the total mass of the particles of the water vapor in the air equals the mass of the water that boiled away. Suppose you tear a 100-gram cardboard box into pieces. The total mass of all the pieces will also be 100 grams. The mass of the cardboard box stays the same. In this example, however, the volume of the cardboard box changes because tearing it into pieces causes it to lose its shape. So the volume of the box would change, but not the mass. Let's look at the total mass of the mixed salad. All right, down here it says the mixed salad is the sum of the masses of the vegetables in it. So that means if we look at the cucumbers that are 75 grams, the lettuce that's 110 grams, and the carrots that are 90 grams. So what would it equal total when we put them all together? The mass of the salad. Well, let's go ahead and everybody open your notebook. In your notebook, it's time for us to label something. Okay. So at the top, you're going to say conservation of mass. This is your science notebook, by the way. Make sure you're in your science notebook. Push pause if you need to get caught up, and push play when you're ready. All right, so if you take a look here, we need to add up the pieces in the salad. I want you to actually illustrate this with me, okay? So illustrate what it looks like in a salad. So we have a salad bowl of cucumbers. I don't know if you guys like cucumbers. I am not a fan of them. A lot of people like them. 75 grams. And then let's also show a bowl of lettuce. And that is 110 grams. And we have another bowl over here of carrots. And that one is 90 grams. Okay, so what would the mass of the actual salad be once you put them all together? Okay, so down here you're gonna write all together the salad's mass equals what? Let's go ahead and add it up. So you need to add these numbers. Show your work. You would get 275 grams. That's because we didn't lose anything from the materials. We poured them directly into the salad. So we didn't change the mass. If you broke up each ingredient, it would add up to the same thing when all the ingredients are together. All right, now let's take a look. I definitely want you to draw the other example that we talked about, okay? Because drawing helps us remember things. So let's go ahead and draw a picture of a cardboard box. Okay, we're gonna do another example here. So we're gonna have a cardboard box, and it is okay if your cardboard box isn't as awesome 3D as mine. There we go. We have a cardboard box, and let's say it was 100 grams. That's our mass. And then we rip it apart into lots of random pieces. What does it all add up to? You need to write that all the pieces add up to 100 grams. Let's look at the next thing. Right here, back at the article. A chemical change turns one kind of matter into another. However, the mass of the matter stays the same. It can be tricky to compare, though. First, you must collect and measure the mass of everything you begin with. Then, you must collect and measure the mass of everything you are left with. When wood burns, it combines with oxygen from the air. Burning produces ashes, smoke, and other gases. The mass of the wood and oxygen equals the mass of ashes, smoke, and gases that are produced. So during this chemical reaction, the flask is sealed. Nothing can enter or leave. So the final mass equals the starting mass of 300 and 2300 grams. Now to do the math chart, we are actually going to do that together in our notebook. So let's go back to our notebook. And right where we were, okay, I think I have some space right here for my do the math. So we are going to go ahead and copy this chart down. Let's see here. Title it, Do the Math. And we'll make a nice chart like this. And we'll put physical change right here. Physical change. And we'll put a line here. This one will be called mass. And that's measured in grams. We're going to go ahead and list, not title, but list sugar as 125 grams and water as a mystery, we're not sure. So that's our variable that we don't have yet. But together, we know the sugar water is 198 grams. How can I find that missing number here? Well, hopefully you're thinking subtraction would be a good way to find the missing number. So you're going to take the total sugar water and you're going to subtract the sugar to find the missing number. So go ahead and push pause and come back and push play when you have that answer. All right, so now that you've found this answer, write it in there. I want you to write it in on your own. And we're going to go ahead and look at a chemical change now. So I'm going to go ahead and label this next part, which is chemical change, because we just talked about a physical one. And of course we have the mass here in grams. And we're going to have iron. That is 519 grams. And then we have oxygen. That is 23 grams. And I want you to figure out what is the grams, what would be the mass for the rest when you put the iron and the oxygen together. So go ahead and do the math by putting those together, and hopefully you know putting those together means you're adding. So show your addition and put the answer here, and then you're ready to submit your work.